I'm delighted to introduce Dr. Yilang Li, who is the major coordinator for our Earth System Science major. And he's going to talk us through that. And afterwards, you'll have a chance to ask some questions. So thank you, Dr. Li.
All right, thank you. I will thank Professor Michael Peterman for coordinating this whole event, and Dr. Jess King for her introduction to geology and also Earth system science. Here I just give briefly an introduction of the what is Earth system science. All right. Okay, I think that's it. All right, can you see my desk? All right, so just very briefly, what is Earth system science? So here is, because Earth system science is, or ESS, is a kind of new science, so we give a definition here. It's basically, it's about the links between the different spheres and also the human impact. So this is one thing a bit different from general earth science or geoscience, because here we emphasize participation of human activity. So we the science or the ESS started from this, like in the early 70s. Scientists began to realize that human activity might have very significant impact to the natural environment, so that they began to think about the influence of human development. So this is here are two scientists, James Lovelock and Lynn Margulis. They have a great contribution to the concept of Earth system science. And this is about the development of this science. We just give a timeline. In the early time, you can see that some of the points are contributions from very significant discovery of Earth science. One example is the discovery of snowball Earth, early proposed by Professor J. Cushman in 1992. There are some other related issues. And this is a structure of Earth system science. You can see that it's very kind of complicated. So basically in this science, we study the connections between the different systems. And you can see that there are two systems might be outside of the Earth system. One is external forcing, basically the sun. Another one is human activity, because we live here and we now, because of our civilization, we are kind of separated from a system, from ecological system, but they are very important external forcings. And here is why we need to have a system science, because in the recent years, ESS is getting to be a very important science, because it led us to understand the interaction between the natural system and the human development. Here I just give a few examples. We are here, and you can see here, this is one example, Alabama University and the UCI, and some others. This is from Penn State, and some where there are many universities now have Earth system science. I just recently have a survey of the universities with Earth system program. I found that I'm very surprised, because now in the Western European countries, there are more than 100 programs with Earth system science. This is a very surprise, because like 7, 8 years ago when I did this survey, it's only a few universities they have the Earth system program. Now there are so many universities they have this program. I think it's because it's getting to be a very important issue of the of the links between human being and the natural system. And so here is why we already have geology, and we still need to have a system science. I think JS has talked about this. Here is just some detailed interpretation of the reason why. One is a logic, because Earth system science uses a holistic rather than reductionist approaches. This is a little bit different from geology and from environmental science. And also we give the difference between the Earth system science and the environmental science. So basically, environmental science is about the immediate environments of human being. And the Earth system science, we talk about the immediate environments, environment change or global change in the recent times, like in the recent 11,700 years. But the geology talk about very, very long history, like billion years, for 3 or 4 billion years. So this is basically different between geology and the system science and the environmental science. One is the time, basically it's a time-space difference. Geology has the longest time dimension, and where it's about the deep time process. And Earth system science is mostly about the recent 11,700 years. But for the environmental science, just modern environments around us. So here is a very complicated diagram. I will not read it, but it just tells us that it's about the recent development of human civilization and how it gradually turned to a force against the natural system. And this is about the time-space boundaries of Earth system and the whole planetary system. And here is about the core courses for Earth system science. So basically, we have this is data process. Is more about the data processing and modeling, and EASC 1406. This is an introductory course, and we have courses about the atmosphere and the hydrosphere and the surface process and remote sensing and biogeochemical cycles. This is a disciplinary core course, and also we have this capstone courses, and then we have some other programs. I think this is something JS didn't mention, but we have all our geology, environmental science, and Earth system science are involved in this program that students will have chance to study overseas. And also we have some other, we have a lot of exchange chances to the international universities. As I remember in the recent years for our system science, we have students go to Rice University, go to Copenhagen University, and go to some others. They are very good universities with very good system science programs. So, so here is about the content of system science. I just listed some. So we talk about the topics, all the teaching programs. We're about the Earth Mother, the concept of Earth Mother, and the numerous cycles of system regulations. I mean the natural ones and plus human impact revolutions in time and Anthropocene. I mean those human impact and the projections, sustainability. I think sustainability is a very, very important topic of this program, of this major, because we analyze all the Earth systems and the human impact, and finally we want to suggest some solutions for the sustainable development of human being and of the natural system. And we will introduce very important concepts. One is the the negative feedback concept, which is very important for the fine-tuning of the Earth systems. And we need to understand this to exert our humane force to the natural system. So this is just one example of the negative feedback to fine-tune the temperature of the Earth system through time. And this is about the fine-tune of the carbon cycle, energy cycle for the Earth system and for the ecosystems. And this is about the new technologies we will use to observe the Earth systems. One is about the changing of the globe change in time and in space. This is about the changing of the glaciers, mountain glaciers through time. And then we want to find out what's happened. What is the natural influence? What's the human input? And this is about the similar observation. Again, we need to find out what is natural system and what is human input to this. And we want to find out how much is human input to the natural evolution of the natural system, which probably is a very important issue for the future development of for the human being. So here I will not read to the very detail. Previously, for the very, very long time, we only have a natural system. But now we need to find out the pathway of the Earth system, of the ecosystem of human being to the future. Okay? And this is some observations we have now. You can see from the left hand is that human influence to the night, which is only happened in the last like 1 century. And in the right panel, you see some pictures like human killing of the sharks or whales. That already influenced the animals system in the ecosystem in the ocean. And also if you are as a student in Hong Kong U, you will have chance to see the wild boar even on campus. So what will be the influence to you and to them? Okay. And okay. So here is one more example of the human impact on the evolution of the natural system. We will see the detail of this in our courses. And also probably the next development will be the digital Earth. Is that good? What is, again, is influence or impact of that to the evolution of the natural system? We don't know. And this about the career is nothing I can tell. So basically, Earth science is here, including geology and Earth system science. And we also have in touch with the life science and physical and mathematics. And with this knowledge of this, we'll integrate with other studies like remote sensing, economy, society, and science and political science, and put all together. We will use system science knowledge as part of our understanding of the whole Earth system and human society, and to make the decision for the society and for the development of human being. Okay, I think this is about the my talk about Earth system science.
Great, thanks very much, Dr. Lee. So yeah, I just looking at after that really interesting talk. So there's a lot of overlap. If you look at the our websites, HKU Earth Sciences website, you can, under the study section, you can actually see the courses for each of these majors, and there is actually a lot of overlap. But there's obviously extra courses in each of those different majors. So we mentioned before about how, you know, the opportunities for our graduates are really great, both in Hong Kong. Our graduates are in demand in a variety of careers. In terms of the Earth system science, Dr. Lee, do you see kind of any general differences in the kind of careers that Earth system science graduates have compared to the geology ones? Because that's quite a common question that we often get, and perhaps some of our viewers would like to have a bit more about that.
Yes, I think we well, I like to emphasize that we have this. Probably we are the only department on Earth, the whole all over the world, that we have Earth science. We have geoscience, we have Earth system science, and we have environmental science. So that is a cover of every part of the concept of environments around human being, with very different time dimension and the space dimension, so that that cover almost every part of the our general environments. And you can see from here is what I see the career different is that Earth system science concern more about impact of human being to the geo system and also to the ecological system. So that I think this will influence the final career of our students. Probably more students will go will find their job more related to the society and to the some government departments, like related to environments, to natural environments.
Excellent. Thanks, Dr. Lee. I think you touched on an excellent point that, we're really lucky to have, geology intensive environmental science and earth system science. It's really rare globally to have all those combinations.
Yes.
And because we have the opportunity, the students have the opportunity to pick, obviously you have to do the core courses for each of the major, but you can pick courses from all those other majors. You can really kind of tailor your experience, your study experience in a way that's very unique, and I think that gives our students really a great lead into careers after their studies. So I think that's a really great point, Dr. Lee. Cool. No, I think that's really great.
Yeah, what Michael said is really we are probably the only one we have very good programs. One example is that we also talk about environmental pollutions in the earth system science. But if you are very interested in this topic, probably you can also check out these teachings in the environmental science, so that they have more detailed courses on environmental pollution, and also some are like students from geology and from environmental science. They can also find out what are those connections between the different parts of the Earth and from Earth system science. So that this is all the three majors are very complementary.
Absolutely. That's exactly. And I think the way that our degrees are structured, as a student, you can start your degree and then experience it and try different things, and then reach what works for you. You don't have to start and then end up doing something. You can experience these different majors at the beginning, and then decide later based on how you feel and what you see. So that's that's excellent. So thanks very much, Dr. Lee. If our listeners would like to have more detailed questions about the Earth System Science major, Dr. Lee is the major coordinator, so please feel free to email him. If you have more general questions, obviously we've got like the departmental email. But yeah, as Dr. Lee was saying, because we have so many degrees that are so complementary, that we can do in the Department of Earth Sciences, feel free to also, for example, if you're interested in one major, feel free to reach out to those other coordinators as well. So I'd like to thank both of our speakers today, Dr. King and Dr. Lee, and thanks for joining us. And we look forward to hearing from you soon. Goodbye.